dreamt at that time of going to the US, working for NASA. That never happened. The excitement of what NASA was doing was what motivated me to take up a career in science and engineering. How long can we depend upon foreign technology?
Chandrayaan-2 is an Indian lunar mission that will only go where no country has ever gone before. The South Polar region.
Our biggest driver is to create we do not rest on our knowledge. We constantly look at challenges. It's a lot of hard work goes planning and program collaboration.
Chandrayaan-2 consists of an orbiter, a lander, and a rover. The orbiter will perform landing from an altitude of 100 kilometers. The lander will make a soft landing on the surface and send out the rover. The Moon is the closest cosmic body where space discovery can be attempted and documented.
Our moon is believed to have formed from the remnant of a giant impact of a Mars-sized solar system object with Earth more than 4.4 billion years ago. Evidence of the early solar system environment in Earth's vicinity is preserved on the moon. This provides ample reasons to use the moon as a nearby laboratory to look back at Earth's history. India's first mission to the moon, Chandrayaan-1, revealed important findings. The direct discovery of water on moon by Chandrayaan-1 in 2008 and further re-examination of retrieved samples for trapped water in lunar rock samples. The very thin atmosphere of the moon, called the surface boundary exosphere, also showed water content quality that can validate or disprove theoretical models. The Chandrayaan-2 mission is designed to provide new and unique observations to help India's scientific pursuits.
Chandrayaan-2 attempts to foster a new age of discovery, increase our understanding of space, stimulate the advancement of technology, promote global alliances, and inspire a future generation of explorers and scientists.
This is a very, very important program for the Indian Space Research Organization and as well as for the space community, which looks at India.
चंद्रमा पर चंद्रयान 2 इसकी सफलता और सफल लैंडिंग भारत को अंतरिक्ष की खोज में और भी आगे ले जाएगी। मैं इस मिशन की पूर्ण सफलता के लिए आप सबको बहुत बहुत शुभकामनाएं देता हूं।
For years, the Indian Space Research Organization, ISRO, has been taking India forward in the space race. The space agency hit a milestone with Chandrayaan-1, and now ISRO is set to make history with the Chandrayaan-2 mission.
I remember when I was about 9 to 10 years old, my mother bought for me a few colorful, exciting books about the emerging technologies of computing and space travels. When I was reading about the exploits of NASA in the US, and I actually dreamt at that time of going to the US and working for NASA. Of course, that never happened, but the excitement of what NASA was doing was what motivated me to take up a career in science and engineering. How long can we depend upon foreign technology in our country?
Chandrayaan-2 is an Indian lunar mission that will boldly go where no country has ever gone before, the Moon's South Polar region.
Our biggest driver
is to create benefits to society, the scientific community and the country at large. We do not rest on past laurels. We constantly look at the future and seek new challenges in everything we do. A lot of hard work goes into conceiving, planning and executing the program in collaboration with various industries.
Chandrayaan-2 consists of an orbiter, a lander and a rover. The orbiter will perform mapping from an altitude of 100 kilometers, while the lander will make a soft landing on the surface and send out the rover. The Moon is the closest cosmic body where space discovery can be attempted and documented.
Our Moon is believed to have formed from the remnant of a giant impact of a Mars-sized solar system object with Earth more than 4.4 billion years ago. Evidence of the early solar system environment in Earth's vicinity is preserved on the Moon. This provides ample reasons to use the Moon as a nearby laboratory to look back at Earth's history. India's first mission to the Moon, Chandrayaan-1, revealed important findings. The direct discovery of water on Moon by Chandrayaan-1 in 2008 and further re-examination of retrieved samples for trapped water in lunar rock samples. The very thin atmosphere of the Moon, called the surface boundary exosphere, also showed water content from Chandrayaan-1. As the global research community continues its efforts to understand the origin and evolution of the Moon, it demands new investigations and higher data quality that can validate or disprove theoretical models. The Chandrayaan-2 mission is designed to provide new and unique observations to help this scientific pursuit.
Chandrayaan-2 attempts to foster a new age of discovery, increase our understanding of space, stimulate the advancement of technology, promote global alliances, and inspire a future generation of explorers and scientists.
This is a very, very important program for the Indian Space Research Organization and as well as for the space community, which looks at India as one of the emerging countries into the space program.
Moon provides the best linkage to Earth's early history. It offers an undisturbed historical record of the inner solar system environment. Though there are a few mature models, the origin of Moon still needs further explanations.
In the past, people had been looking at from their naked eye the stars, galaxies and constellations. We are actually hindered by the atmosphere of the Earth. So if you go beyond the Earth's atmosphere, then you have a very good view of the celestial objects. As the technology started developing, man started putting satellites into orbit and putting observation instruments on those satellites to look at celestial activities. Remote sensing is the art of looking at things from a distance and deciphering or understanding activities. It's the only mechanism through which we can do observation of celestial objects. It was one such measure where our own Chandrayaan-1 actually carried a set of observation instruments like MQ or ISRO, which helped discovering not only the presence of water molecules and white molecules, but also the process of formation of such molecules. The instruments which can make observation in a large number of wavelength spectrum, it can actually identify the characteristics of the surface of the Moon. We are now going to follow up the activities of Chandrayaan-1 with our own Chandrayaan-2, which will be enhancing what we have identified and make it more concrete, both in terms of the presence as well as distribution of water on the Moon.
Extensive mapping of lunar surface to to study variations in lunar surface composition is essential to trace back the origin and evolution of the moon. Evidence for water molecules discovered by Chandrayaan-1 requires further studies.
Space missions are complex and risky, more so for a mission to Moon and other planets. We have a track record. Chandrayaan-1 of 2008 and the Mars orbiter mission Mangalyaan of 2014. They tested our ability for precise navigation into deep space and for the tricky capture of the orbit of these celestial bodies. Chandrayaan-2 mission is more intriguing. Imagine the lunar lander orbiting Moon at a speed of around 6,000 km per hour. It must have autonomous capability to break its speed and steer itself for a soft and safe landing in an uncharted terrain of Moon, that too precisely at the designated site. And what more, all this happened within 16 minutes, and the landing site also has to be ascertained by itself while on its descent. What drives the team ISRO to such quantum leaps? It is the belief in ourselves. It is team excellence. It is the learning from the past missions, both failures and successes. It is a sublime combination of the wisdom of elders and the innovative power of younger generation. It is a preparedness for all imaginable scenarios. It is transformational leadership at all levels.
The lunar South Pole is especially interesting because of the lunar surface area here that remains in shadow is much larger than that at the North Pole.
Chandrayaan-2 is the next leap in technology as we attempt to soft land close to South Pole of Moon. The soft landing is extremely complex and we will experience approximately 15 minutes of terror.
There is a possibility of the presence of water in permanently shadowed areas around it. Chandrayaan-2 will attempt to soft land the lander Vikram and rover Pragyan in a high plane. First space mission to conduct a soft landing on the Moon's south polar region. First Indian expedition to attempt a soft landing on the lunar surface with homegrown technology. First Indian mission to explore the lunar terrain with homegrown technology. Fourth country ever to soft land on the lunar surface. Chandrayaan-2 will be aided in achieving its mission by some of India's most advanced engineering marvels. Its integrated module, which comprises technology and software developed across the country, includes ISRO's most powerful launch vehicle to date and a wholly indigenous rover. Chandrayaan-2 is on a mission unlike any before. Leveraging nearly a decade of scientific research and engineering development, India's second lunar expedition will shed light on a completely unexplored section of the Moon in South Polar region.
Moon is the closest cosmic particle near the Earth. So it was always very, very interesting for human being to understand about the Moon. Chandrayaan-2 is going on a particular place on the area where no country has reached. That area is South Pole of the Moon. Chandrayaan mission will inspire and motivate the youth of the society and the children and the student to come out of the comfort zone, think bigger and go beyond what is already achieved.
This mission will help us gain a better understanding of the origin and evolution of the Moon by conducting detailed topographical studies, comprehensive mineralogical analysis, and a host of other experiments on the lunar surface.
Is a 4-meter diameter class rocket with a payload capability of 4 ton to GTU. This is a rocket that is going to carry our Chandrayaan-2 to the mid-orbit. The GSLV Mark III is signified with a very elegant architecture in which we use one of the biggest solid boosters called S200 as strap-ons for the first stager. Then we use a liquid stage Vikas engine based L110 and a cryogenic upper stage, a new cryogenic upper stage with the C25 stage with the CE20 20-ton thrust cryogenic engine, which is an indigenous development. It also features a payload compartment which is 5 meter in diameter, giving almost 100 meter cube payload volume. Balancing of these two motors to provide very equal thrust in a solid motor was one of the important challenges which was addressed in the design and its processing and casting and testing of these motors.
5, 4, 3, 2, 1.
India's GSLV Mark III M1 successfully launched Chandrayaan-2 from the Satish Dhawan Space Center, Shar, Sriharikota, on July 22, 2019 into its planned orbit.
I am extremely happy to see that ISRO is now embarking on one of the most complex missions that is undertaken since its inception, that of launching the Chandrayaan-2, which has got an ambitious mission goal, that of putting a craft around the moon as an orbiter and then take a part of it and land it on the surface of the moon, the lander, and ultimately deploy out of this another craft that would do a little bit of roving around the vicinity of the landing and search for itself certain features of the moon, the geological and other aspects of the lunar surface.
ISRO aims to expand India's footprint in space. Inspire a future generation of scientists, engineers, and explorers. Surpass international aspirations. Let us hear from Dr. A. Rajarajan how Chandrayaan-2 was successfully launched.
A lot of things happen behind the scenes for a successful launch. The integration of the launch vehicle happens over a period of 50 days. The activities are carried out 24/7, round the clock, in a highly synchronized manner, which is the hallmark of the resilience of Team ISRO. Favorable weather and wind conditions are a must for successful launch. Planning a launch requires accurate weather and wind profile modeling and prediction for the launch date. Ensuring safety at all work sites requires elaborate planning and assessment of accident risks. The liquid fuel is loaded in launch vehicle hours before the launch. Ensuring adequate supply and accurate loading requires careful monitoring of this activity. All activities before the launch till liftoff are controlled and monitored by the Mission Control Room, which has a system to assess the flight data from the launch vehicle. Spent stages of the rocket are separated and fall back on the earth along the ground trace. Careful analysis is done to predict the impact location of these spent stages to prevent any mishaps. Just after the lift, the flight data are received using the ground-based radar Aksha. And this is how a successful launch is executed.
3, 2, 1.
After the injection of Chandrayaan-2 spacecraft, a series of maneuvers were carried out to raise its orbit and put Chandrayaan-2 on lunar transfer trajectory. On the day of landing, the lander will separate from the orbiter and then perform a series of complex maneuvers comprising of rough braking and fine braking. Imaging of the landing site region prior to landing will be done for finding safe and hazard-free zones. The lander Vikram will finally land near South Pole of the Moon on September 7, 2019. Subsequently, rover will roll out and carry out experiments on lunar surface for a period of 1 lunar day, which is equal to 14 Earth days. Orbiter will continue its mission for a duration of 1 year. For understanding of the lunar composition, it is planned to identify the elements and map its distribution on the lunar surface. Orbiter, weight 2,379 kg. Electric power generation capability, 1000 watt. At the time of launch, the Chandrayaan-2 orbiter will be capable of communicating with Indian Deep Space Network (IDSN) at Bailalu as well as the Vikram Lander. The mission life of the orbiter is 1 year and it will be placed in a 100 by 100 kilometer lunar polar orbit. Lander Vikram, weight 1,471 kg. Electric power generation capability, 650 watt. The lander of Chandrayaan-2 is named Vikram after Dr. Vikram A. Sarabhai, the father of the Indian space program. Vikram has the capability to communicate with IDSN at Bailalu near Bengaluru, as well as with the orbiter and rover. The lander is designed to execute a soft landing on the lunar surface. Rover Pragyan, weight 27 kg. Electric power generation capability, 50 watt. Chandrayaan-2's rover is a 6-wheeled robotic vehicle named Pragyan, which translates to wisdom in Sanskrit. It can travel up to 500 meters and leverages solar energy for its functioning. It can only communicate with the lander. Around 70 students from across the country will be watching Chandrayaan-2's scheduled soft landing on the moon as it happens in the early hours of Saturday. The students will watch Chandrayaan-2's moon landing live along with Prime Minister Shri Narendra Modi.
Excited about the soft landing and the rover. I'm aware that it's very critical to soft land precisely on the moon surface, especially after the failure of Israel lander.
It's going to be a very huge scientific knowledge mission, and for the whole of nation, it's going to be a national pride. Each one of us is going to enjoy and prove to ourselves and to all the nations around the world that ISRO is capable of achieving anything.
I'm very proud to be an Indian, as India is launching on biggest and greatest mission, Chandrayaan.
We always see that students either want to become doctors or want to become engineers, but when things like this come up, we can see that there are other opportunities out there. It's not just doctors and engineers or other careers people choose. There's science and technology. Our country has so many resources. We have the ability to come forward by so much.
It's going to be a successful mission because ISRO has been achieving marvelous feats recently.
I hope that this Chandrayaan-2 is a success and that students like us can be working on Chandrayaan-3 and 4 and so many more.
ISRO will continue in its endeavor to provide many such deeply explored space programs in the near future.
संस्कृत जगत की हलचल।
जय जय हे महिषासुरमर्दिनी ज्योति कलश लवते।
आधे घंटे में सब कुछ सरल संस्कृत में।
संस्कृतस्य वर्णशास्त्रं व्याकरणशास्त्रम् एतानि सर्वाण्यपि अत्यन्त वैज्ञानिकानि।